Hi everyone! I'm about to show you functional demo of the project that is called MStar. It is truly a next-generation knowledge inference engine, and I hope you like the product at the end. So the first question is, what does it do? In this demo, I'm going to show you how easy it is to ingest your documents. This includes PDFs, Excel sheets, Word files, and other formats. But that's not all. MStar can also work with structured data. That means you can connect directly to your database, and as soon as you start asking questions, MStar will automatically query it in real time. Along the way, you'll see how we're building something called a concept-type graph. Now, you may be wondering, what's the difference between a concept-type graph and a knowledge graph? We'll walk through that together. Finally, I'll show you how you can interact with your data, asking questions, exploring insights, and leveraging everything MStar has processed for you. So the main question is, what does it really mean to speak to your data? And why do you need it? In daily business activities, we often run into the same problems. We need someone to build dashboards. We need experts to process unstructured data and extract insights. Sometimes, we don't even know where that data lives or who in the organization actually understands it. And most of all, we just don't have time for this. That's why MStar makes a difference. Instead of waiting for dashboards or depending on experts, you can simply ask your data questions directly. MStar processes, extracts, and analyzes the information for you, revealing the hidden patterns and insights you need right when you need them. So with all that being said, let's take a look at the current solution space. Today, many organizations rely on what's called a RAG application, Retrieval Augmented Generation. The idea is simple. You pass a document into the system, it breaks the document into chunks, and then stores those chunks in a vector database or local storage. When you ask a question, the system searches through all the chunks and returns the ones most similar to your query. Those chunks are then passed to a large language model so the model can generate an answer based on them. Now, while this sounds powerful, there are some serious limitations. First, RAG doesn't really understand the semantic relationships between chunks. It's just slicing documents by size, for example, every 500 words. That means important connections across the document can get lost. Second, it can overload the model with too much information, which leads to irrelevant or confusing answers. And third, integration into real-world applications is still complex, and when dealing with very similar but slightly different pieces of data, RAG often fails to identify which detail actually matters for the business. So while RAG is a great first step, it's clear that we need something smarter, something that truly understands the relationships inside the data. Now, let's look at the second type of solution, GraphRag. GraphRag is essentially an extended version of RAG. Instead of just breaking documents into chunks, it goes a step further. It decomposes the information into entities, like people, companies, or metrics, and then connects those entities into a massive graph. The idea is that when you search, GraphRag doesn't just look at isolated chunks. It points you to a relevant cluster in the graph, then dives inside that cluster to find the information that might answer your query. Setting up and maintaining the knowledge graph is complex, and it requires specialized technical expertise. You also need to duplicate data once in the database and again in the graph, doubling both storage and maintenance costs. And even then, you still spend time cleaning and validating the data it uses. That makes it resource-intensive, and sometimes the output is redundant or noisy. So while GraphRag offers richer relationships, the cost, complexity, and overhead make it hard to adopt as a practical solution for most businesses. Another type of solution is GNN-based solutions, where GNN stands for Graph Neural Networks. These are extremely powerful models. They can capture complex relationships across entities and provide deep insights. But in practice, they come with major challenges, very similar to GraphRag. Maintaining them is expensive. You need to train models, manage machine learning pipelines, handle data versioning, model versioning, evaluation, the entire life cycle. And while they're a hot area of research, there really isn't an enterprise-ready version you can just pick up and use as your base solution today. So while GNNs are powerful, building, maintaining, and actually using them is difficult. The fourth type of solution is LLM fine-tuning. This is one of the most common approaches right after RAG. The idea is to pass large amounts of data into a language model and fine-tune it so it learns your domain. But here's the problem. Once the model has learned something, it's there for good. That means if you have privacy concerns, or if your data has different levels of access or sensitivity, fine-tuning isn't safe. It essentially exposes everything to everyone. LLM fine-tuning is great for general use cases, but when you're dealing with unknown domains, strict privacy, or hierarchical access to data, it simply doesn't work. Now, let's shift gears and look at the business expectations you probably have when adopting a solution like this. First, you want to save time and boost productivity. The solutions we've just discussed, RAG, GraphRag, GNNs, and fine-tuning, can help in certain ways. But the hidden cost is the time you spend just making them work, maintaining them, and keeping them in production. Second, you want to reduce costs. A real solution should save your business money, not generate additional overhead in infrastructure, expertise, or duplicate data pipelines. Third, you need reliable and actionable insights. If you're going to use an LLM-powered application as a decision-making tool, you need to trust it. That means answers should be transparent, traceable back to the source, and explainable. And finally, you need ease of use and scalability. The solution should grow as your data grows, without making things more complicated for your team. With those expectations in mind, let me now walk you through the core functionalities of the app. First, I'll show you how we process unstructured data, like PDFs, Word docs, and Excel sheets. Then, I'll show you how we process structured data directly from your databases. Shall we jump into the demo? Let's go. Once you log into the platform, you'll be redirected to the Project Manager. This is where you can create a new project and start processing your data. The layout is designed to be simple and intuitive. On the left side, you can navigate through menus. Profile is where you can find your personal information along with token usage. If you want to process your files, first step is File Manager, where you can upload your files. These files are needed when you make projects in this platform. Let's define a project. Start with a name. Next is to tell MStar your industry or semantic domain. As an example, you can consider transportation or healthcare. MStar is domain agnostic and does support a wide range of domains. Our document is related to road transport, so I will choose transportation. For processing files, choose Upload Files mode. Then select the uploaded files and click on Create Project. Congratulations for creating your first project. Now you need to run the project, and by that, Server will process your document and build your concept type graph. For processing, let me show you an example of a document. As you can see, it's a combination of text, images, and tables, all in one file. It's a fairly complicated document, very similar to the type you probably encounter in your day-to-day work. All right, once the project is done, for this document, you take around 3 to 5 minutes to complete, and it's about 50 pages. So it really depends on the size of the files that you are putting here. All right, once the document is processed, the next step is to select your active project. In my case, the transport project. From here, we move into the concept type graph, and this is where things get interesting. All right, let's give it a moment to load. Now what you see here are the concepts that have been extracted from the document. This is not a knowledge graph. It's much smaller and more lightweight. And it's also not an ontology, because it carries more information and is less abstract. Concept type will capture semantic relations between concepts extracted from the documents. If we zoom in, you'll see that it's essentially all the concepts or semantic types within the document, extracted and connected to one another. Here's why that matters. When you ask a question, MStar uses this concept type graph to identify relationships between entities and locate the source information that can be used to answer your query. The key difference from a traditional knowledge graph is that a knowledge graph tries to store all the data. Concept type graph does not. There are no raw data values here, only concepts and their connections. That makes it very secure to share, since no private information is exposed. And, because of its small size, it can even be stored locally if needed, or scaled depending on the complexity of the application. In short, this concept graph represents the core knowledge MStar needs to generate reliable answers to your queries.